Hello and welcome to Dialogue. China's FAST, the world's largest single-dish radio telescope, has opened to global scientists and accept observation applications from March the 31st. Well, China's Sky Eye has become more important to radio astronomy since Puerto Rico's Arecibo telescope became damaged and non-functional at the end of 2020. So, what opportunities will China's telescope offer for scientists and international cooperation? And what are they looking for out there? To discuss these issues, I'm joined in the first part of the program by Dr. Peng Bo, director of the Key Laboratory of FAST at the Chinese Academy of Science. That's our topic. I'm Zhou Yue. Mr. Peng, you are a member of the FAST project. It is short for 500-meter aperture spherical telescope. And what is outstanding is that it has a dish area as large as 30 football fields. So it's not just a normal telescope. Tell us about the size, why it needs to be this big.
The FAST was born in China's attending the International Cooperation Project, SKA, the Square Kilometer Array, which is made of many telescopes with a collecting area of 1 square kilometers in order to answer some basic fundamental questions about universe, such as the origin of the first galaxies. But how to build the SKA? There are two ways to realize. Firstly, we can construct it with many dishes of small diameters, like 50 meter in diameter, which is the current SKA engineering design. The other way is to build it with some tens of large diameter dishes, such as 30 Arecibo-like telescope. China took the later way, proposed to build one Arecibo-like telescope as the SK Pathfinder. The 500 meter in diameter is chosen to be the right and the practical size in order to double the sensitivity as well as the sky coverage of the Arecibo telescope. Therefore, the FAST was named in 1997, which stands for 500 meter aperture spherical telescope.
It is a very ambitious project, but could you please explain to us why a radio telescope is different from an optical telescope? What work will it do?
Yeah, there are two key parameters to measure a telescope's capability, the sensitivity and the resolution. With a huge collecting area, FAST is now becoming the most sensitive telescope in the world. That's unique advantage compared to other telescopes. That means we can see what the others can't. Wonderful achievement. For example, in 3 years, FAST detected more than 300 new pulsars, which is about 10% of the total number of pulsars discovered by all radio telescopes in the world over the more than 50 years. It's a great achievement. I'm quite proud of that.
You earlier mentioned that China wanted to build a telescope that is like Arecibo, but the Arecibo telescope was actually in Puerto Rico. It became damaged and non-functional. So do we have to worry about the damage to FAST, and what kind of maintenance does it need?
The Arecibo telescope is aged before it's gone. After 57 years operation, the direct cost to make it damaged is broken of supporting cables of the tower and the destruction of the dome, and then the big dish destroyed. The Arecibo would be possibly further hurt by more frequent hurricanes and stronger earthquakes than ever in recent years, and the lack of maintenance with limited budget over the decade. I felt very sad that our Arecibo telescope is gone. But we all know it has a great life, bringing us new knowledge to understand our universe. I must thank the Arecibo colleagues who helped a lot about fast construction in the past. After we learned a lot from Arecibo, I don't see any threats to the safety of FAST, which is a well-designed big dish in terms of safety. And it is new and young with an energetic operation team, plus enough budget with strong support from government for routine maintenance. There is one threat to astronomy, not only for FAST or for radio. That's from some thousands of even more satellites to come, which need to be coordinated properly with mega constellations.
I presume a lot of young people who are curious about science wonder how it is your work going on there. Can you tell us what do you do every day, and what are the scientists' schedule like?
Well, it sounds mysterious, but not a secret. You know, the major job in any astronomical observatory is to run the telescope. The daily work in any radio astronomical observatory is similar, but different compared to the optical ones. The optical telescope operates in the dark to observe the stars like sun, but far away from the Earth. Observers stay up all the evening and have to sleep in daytime.
All right.
The bio clock shifts 12 hours. The radio telescope, like FAST, operates day and night for 24 hours to explore the invisible universe. Observers' bio clock shifts in 8 hours. FAST has to be run by 3 groups of operators every day, each of 8 hours. Furthermore, operators change every 6 days, transport by observatory car between the FAST site and the Guiyang, the capital city of Guizhou province, in a distance of about 200 kilometers. What do I do there? I have been one of the builders for constructing the FAST. Since the beginning, I spent 24 plus more years there. Now I'm one of the ordinary users for FAST. I have been working on and will apply for the call for proposal to work on studying pulsars, actual galactic galaxies, together with my collaborators. Thank you.
So you've been building this telescope and working on the telescope for more than 20 years. And I know this month, the telescope is going to be opened to the global scientific community. And we were told that 10% of the observation time will be given to international scientists. Can you tell us why 10% and what are the criteria for deciding which scientists get the time?
FAST is a national make-sense facility fully funded by Chinese government. It should be served the Chinese astronomical community. Overseas are welcome to participate in collaboratively way. It's normal to assign some open time of the telescope for international users in order to expand telescope's impact on science outcomes. One Earth, one sky. We therefore decided to open the telescope time to the world gradually and start from 10%. which is quite a big piece of cake. Some telescopes open only 5%. So I think this is the Chinese contribution to the radio astronomy in the world.
Can you
Thank
tell
you.
us how the data will be shared among the scientists through international cooperation, and what particular areas they are looking at right now?
Well, any approved researchers through this call for proposal for faster science observations have a proprietary period of 12 months for data use first among a team or collaborators. But any other people who is not part of the project can access the data during this period after contacting the principal investigator and approved by the PI. After 12 months, the data will be released to public use to serve a broader community for further exploration and discoveries. Due to the bandwidth limitation, it's not practical to transfer the huge amount of data from the FAST observatory over the internet. Thus, it is encouraged to make direct copies of data with hard disk at the FAST data center. And all the observing proposal will be valued by international expertise, and some may be accepted, then can start to be observed by FAST. And there are many interesting science topics, and nowadays mainly on pulsars. We may find new types of pulsar, such as the neutron star and the black hole binary system. Thank you.
Okay, pulsars, neutron stars, and black hole binary system. Thank you very much, Mr. Peng, for your insights and your ideas about how China has been doing to help humans understand the universe. Thank you. We'll take a short break and be right back. And continue our discussions on FAST, China's radio telescope. I'm now joined by Dr. Michael Kramer, Director of the Max Planck Institute for Radio Astronomy in Bonn, Germany, and Dr. Robert Brown, SKA Science Director in the UK. So, Dr. Kramer, could you please tell us what kind of international cooperation can we see from FAST telescope?
Well, FAST will open up its observing time to international observers. So I expect that a lot of people will take the opportunity to use the telescope to explore the universe, and by doing that also cooperate with our colleagues in China, which we know very well, but that open up new possibilities of collaboration. So really looking forward to that.
And Dr. Brown, I know that it has opened the platforms to international scientists from April, but what particular areas will be the interested parts?
Oh, well, where do I begin? There are so many of them that are of
What about the
interest.
most important one, the top priority?
The top priorities. Well, what sets FAST apart is its extreme sensitivity, the most sensitive radio telescope on the planet in operation. And what that enables is very sensitive observations of faint sources on the sky. It can explore parts of the universe that we've had great difficulty looking at previously. For example, finding the most extreme pulsars that might be in orbit around a black hole, so that their properties are changing very rapidly, and you require extreme sensitivity to detect them before they change too much to identify. So that would be very exciting.
Before FAST and Arecibo, what are the instruments for scientists to observe pulsars, for example?
Well, I'll let my colleague, Dr. Kramer, answer since this is his area of expertise.
Dr. Kramer, could you please weigh in?
Yeah, I have to say, we try to put our hands at every telescope we can use to observe pulsars. They're actually rather faint objects. They're quite small. They're only 20 kilometers across, so we need the biggest telescope to actually detect their signals. And we have used telescopes really across the world, from Australia to our own telescope in Germany to the US. And FAST is just a different scale now. With FAST, we really have a sensitivity to look even deeper and maybe even find pulsars in external galaxies. That's one of the science goals of the telescope.
Can you tell us what is the aim of looking and observing pulsars?
Pulsars are the remnants of the explosion of really massive stars, and they leave over this very small compact object, which is very dense. It's the most dense object that we can see in the universe. And so they also act like cosmic clocks.
It's as dense as black hole, as we understand it?
Black holes are very difficult to observe. We can take pictures, but only indirectly. But here we can actually get the signals right from the neutron stars, which are sort of the most dense material that we can observe. Black holes, we don't see the inside. But what, of course, as Dr. Brown says, we try to find some black hole orbiting a pulsar. And then we can test Einstein's theories to an extreme that we couldn't do so far.
Can you tell us some of the interesting pulsars we found and what kind of knowledge we have gained from observing them?
We have found particularly an object where we have two pulsars orbiting each other, and they are so far the best probe that we have for understanding gravity. They are providing the most precise test of gravitational theories in strong gravitational fields. So it's really complementary to the other methods that we have, like gravitational wave detectors or other experiments in the solar system. So it really opens up a new parameter space.
We know we have other telescopes on Earth, optical telescope, and we have also Hubble telescope up there. Can they do the same job?
No, I mean, something that people should understand is just that every telescope plays a different part of putting the full picture together. The Hubble telescope is excellent in the optical portion of the spectrum, but we need the radio telescopes to actually probe the lower radio wavelengths and allow us to detect the phenomena that in some cases are only ever seen at these radio wavelengths. And so every piece of the puzzle fits together, and together that forms the whole picture. But it's only by using all these telescopes to play their role in putting that picture together that we can really gain understanding.
And besides pulsars, what are the other things we're looking at through this radio telescope?
Well, the other really important areas for FAST will be the detection of neutral hydrogen in external galaxies. This is
could you please explain what is neutral hydrogen to us?
Well, I was about to say that hydrogen is the most common element in the universe. It's the simplest element. It's just a proton and electron. But
the elements of the sun.
Yes, indeed, and within the sun, within the universe at large, hydrogen is by far the most common of all the elements that are out there. And it has a wonderful transition at radio frequencies that allows it to be seen, even though otherwise it would be essentially invisible. But this radio wavelength of 21 centimeters, as seen at nearby distances, allows us to see the neutral hydrogen all throughout the universe. And it allows us to see the way our own galaxy rotates, and allows us to see in the plane of our galaxy, which is invisible at optical and infrared wavelengths, but we can see it with at radio frequencies, and using the neutral hydrogen emission line. And similarly, we can see this emission line with enough sensitivity out to the edges of the universe. And that's why a great sensitivity is so vital to further this type of science.
So, with this better understanding about neutral hydrogen, does it mean we have more knowledge about how the universe has been evolving?
Oh, absolutely, absolutely. This is one of the fascinating things that we see, that the amount of hydrogen within the universe has changed dramatically from a time where it was almost all neutral hydrogen, and then it became ionized. It became exposed to ultraviolet radiation from early stars that might have formed, and in fact, from black holes that might have provided heating and ionization of the hydrogen, that it all became ionized apart from the pockets of gas around objects like our own galaxy that could then form stars from the collapse of that hydrogen. So it is the fuel that fuels all of the stars, which then led to the more complex elements, carbon and nitrogen and oxygen, that make people. So this is where we all arose from, ultimately, from the hydrogen that once dominated.
Dr. Kramer, what is the current level of radio astronomy in the world? And as scientists, what are you looking at for some breakthroughs in our understanding about the universe with instruments here on the ground?
So radio astronomy is actually rather young science still. It's less than 100 years old, but obviously it has made some great discoveries from pulsars, from the cosmic microwave background, from seeing how the universe expands. So it is actually a rather unique tool to look at the unknown processes. And so I expect from FAST and radio astronomy in general, because we are in a golden era. The era of discovery has really not stopped in radio astronomy. And it is, you can see it in the Nobel Prizes that are giving to radio astronomers over the years. And so with this FAST, we actually open up a new parameter space. And that's the most fascinating one, because we know as long as you open up new parameter space, you explore new things with better sensitivity, you're bound to find something unexpected. And yes, we all have expectations, FAST will do this and that, and also that one. But at the end, it's really the unexpected discoveries that will blow us away because we didn't expect them, which I think FAST will become famous for. And maybe you should ask us in 5 years again what FAST has found in intermediate time, because I'm very much sure that the most fascinating one is something we can't even think of today.
I know that a lot of applicants have already expressed their interest in using FAST to do their research, but not all of them can get their desired hours of using it. What do you think should be the criteria of selecting items or research projects?
Well, I'll happily give this a try myself in terms of providing an answer. Well, it's a process that all radio observatories, all observatories of all kinds around the world face on a daily basis. There are often 4 times or even 10 or 20 times more requests for using those facilities as there are hours to distribute. And so what has emerged is a method of looking at all the ideas that are submitted by people, to have them reviewed by fellow scientists and graded in terms of how important they appear to be. And these days, this all happens blindly, so there is no knowledge of who is submitting the proposal. So people are only meant to be guided by the quality of the ideas, with no knowledge about where the scientists are located, who they are, so that their reputation shouldn't play a role in this. But it's just the quality of the ideas themselves that is meant to lead to whether or not they're successful in getting the time on the system.
The reason I ask this, because you are exploring the frontiers of human knowledge. Probably nobody knows in what area what will be found and how important that will be for humankind. So that's probably a very big challenge.
Absolutely, it's huge.
It's a huge challenge. I mean, but that's, I think, where the people who decide, I think they should be open-minded and be happy to risk some observing time to try some, I wouldn't say crazy idea, but say unlikely idea, which may pay off. We have this concept of high risk, high gain. yes, you can produce publications and standard output of a telescope, which is all brilliant. Nothing wrong with that.
Can you
But
give me
once in
one
a while,
example of high risk, high return?
for instance, if you were to tell me, there's a position on the sky, I have some chance that there is a pulsar black hole system, for instance, you should spend all the time looking at that, regardless of how long it will take, because at the end of the day, you may be right, and yes, you have invested in maybe some amount of observing time, but the payback, if you find a system like that, would be enormous. Or just any other new idea that really gives a completely new insight in how the physics may operate in the universe. That are the kind of really fundamentally the game changers that really changed our thinking. It's go back in the discovery of the cosmic microwave background was a complete random thing, at least when it happened, and has changed our understanding of the universe so completely. We understand now how it was sort of formed in a Big Bang and expanded. That has really changed our minds. That kind of ideas that we're really looking for.
Let me also ask a popular culture question. When I was a kid, I watched Carl Sagan's Cosmos, and it tells us that it might be a chance for us to get in touch with alien cultures. So will FAST serve that purpose? Because we might pick up radio signals from extraterrestrial life.
Yeah, well, there are two ways to go about this. One is the directed search approach, and it's, I think, quite likely that such observing proposals will be submitted to FAST, whereby groups spend time thinking about what is the most effective strategy to undertake such a search. But I think the other method is happening, in fact, all the time, whereby everyone who makes use of a telescope to do something that hasn't been done before is looking at their data with a very open mind.
So you're saying it is possible, but very difficult?
Yes, but as we've said, when one has a new capability, things become possible today that were impossible yesterday. And it's having that open mind to recognize new discoveries when they occur. That's the really vital thing, and not to go into this with preconceptions about, oh, I'm only looking for whatever I've imagined. Because nature is much, much more imaginative than we are. In terms of always surprising us with unexpected discoveries if you have your eyes open for them.
And Dr. Kramer, what would be the most exciting discovery using FAST, in your opinion?
Yeah, if I had a crystal ball, I would do that. I think, yes, if you would find signs for extraterrestrial life, I think that will change humankind, obviously. But we'll see how likely that is at the end. But I think finding unexpected things, really, I really want to be surprised by FAST, and I know FAST will surprise us because with that sensitivity, for me as a pulsar person, yes, I do want to find this pulsar black hole system, but I'm really looking forward to the things I can't yet imagine. And, so I think we should be all very excited and see what FAST will come up with in the next couple of years.
Yeah, to discover the unknown. That should be the aim of the scientists. Thank you very much, Dr. Kramer and Dr. Brown. Thank you. And you've been watching Dialogue here on CGTN. I'm Zuri in Beijing. Thank you for watching.